Hello, my name is Nick Madrid, and this is a video tutorial to demonstrate basic XBee communication between the PSoC 5 dev kit and MATLAB. To demonstrate the communication in this video, when a button on the dev kit is pushed, we will send a specific number from the dev kit XBee to the MATLAB XBee, which we will then read in through the MATLAB command window. Then, we will toggle an LED on the dev kit on and off by sending ones and zeros from the MATLAB XBee to the PSoC XBee. You'll need two XBees. In this tutorial, I'll be using the XBee Pro Series 1 modules. The PSoC DevKit XBee will be using this adapter, which can be found on Adafruit, and it allows us to plug it into the DevKit breadboard. To integrate with MATLAB, we'll be using this USB XBee adapter board. And lastly, you'll need the PSoC 5LP DevKit, which can be found on Cypress's website. Next, let's take a look at the software that's going to be needed. You'll first need Digi's XCTU program, which can be found on their website. Then you'll need PSoC Creator 3.0. And lastly, you'll be needing MATLAB, and in this tutorial, we'll be using the 2014 version.
We'll be getting started with configuring the XBees with XCTU. For this part, you'll need two XBee modules, the XBee USB adapter board, and a USB to micro USB cable. Plug the first XBee into the adapter board, like so. Put one end of the USB into the computer and the other end into the adapter board. With the first XBee plugged into the adapter board, open XCTU. Click the Discover Devices button in the upper left-hand corner. The XBee will show up on the list as USB serial port. Check this box, click Next, and click Finish. Once the XBee shows up in the list, click the Add Selected Devices button. The XBee will show up in the list on the left. Click it, and XCTU will read all of the parameters from the XBee. With the menu on the right, we will be able to edit all of the parameters on the XBee. For simple communication, we must change four parameters: the channel, the PAN ID, the destination address low, and the MY address. In order for two XBees to communicate, they must be on the same channel and same PAN ID. The channel is a hex number between C and 17. The PAN ID is any 4-digit hex number. In order for one XBee to send information to a second XBee, the destination address low must match the MY address of the other XBee. In this example, we will use a MY address of 0 for the first XBee and a MY address of 5 for the second XBee. Therefore, for the first XBee, the destination address low must be 5, as this is what we will set as the MY address of the second XBee. Another optional parameter is a node identifier. For this example, we will call this PSoC_XBee, since this is the XBee we will integrate into the dev kit. We will be using the default baud rate of 9600. Once you've set these parameters, click Write Radio Settings. XCTU will write the parameters to the XBee. Anything that shows up as blue has been changed from the default. To verify that everything is correct, you can hit the Read Radio Settings button and XCTU will repopulate the list. Once the parameters on the first XBee have been verified, we will move on to the second XBee. With the second XBee plugged into the adapter board, once again click the Discover Devices button, check the box for USB serial port, click Next, and click Finish. Add the device to the list and select it to read the parameters. Now we must match the same channel and PAN ID with this XBee as we did with the first XBee. In this example, we use 10 for the channel and 3560 for the PAN ID. Additionally, since the first XBee had a destination low of 5 and a MY address of 0, For the second XBee, we must have a destination address low of 0 and a my address of 5 so that the two can communicate. Plus, since this is the XBee we will integrate to MATLAB, we will call it MATLAB _ XBee. Write these settings as we did previously. Read them to verify that it's correct. Now that the parameters on both XBees have been set, they can communicate with each other. As a quick summary, here are the parameters that we changed on the two XBees. In this segment, we will be attaching the XBee module to the PSoC. Take the second adapter board for the XBee and insert the PSoC XBee into it. Now, using the breadboard on the PSoC dev kit, insert the XBee. To interface the XBee with the PSoC, there are 4 pins that we'll need to access. The first one is 3.3 volts. Using the 3.3 volts on the side here, plug one wire there, and the other end into the 3 volt line displayed on the adapter board. Next one is ground. On the PSoC dev kit, this is VSSD, which will go to ground on the adapter board. And the other two are TX and RX, which stand for transmit and receive. The first one, which is transmit, will go to pin 6_0. The second one, receive, will go to pin 6_6. On the adapter board, pins TX and RX are labeled, so plug the pins into the recording. Once this is complete, we have configured the XBee so it can interface with PSoC. In this segment, we will create the PSoC project that is going to run on the dev kit. But first I'll explain a bit about what we're trying to accomplish. To display the basic communication, when a button on the dev kit is pushed, we will send the number 123 from the PSoC XBee to the MATLAB XBee, which we will then read in through the MATLAB command prompt. Then, when a 1 is sent from the MATLAB XBee to the PSoC XBee, we will turn an LED on the dev kit on, and when a 0 is sent across, we'll turn that same LED off. In PSoC Creator, create a new project. Choose PSoC 5, give it some meaningful name. We're first going to make the top design. So we'll bring in the digital input pin for the button. Double click it to configure. We do not need a hardware connection. In general, we are going to make it a resistive pull-up, and the interrupt will be falling edge. Click apply, hit OK. Since we want an interrupt when the button is pushed, we'll bring in an ISR, and we'll wire those two up. Weird looking wire. We'll call the ISR button _ ISR, and we'll call the digital input pin button _ in. Next, we'll need a pin for the LED, so this will be a digital output pin. Bring that in. Call it LED _ out. We do not need a hardware connection, and strong drive is fine. So we'll apply that. The last thing we'll need is a UART block. Now the UART block represents the XBee. So we'll double click it to configure. I'm going to call it XBee _ UART. We want to transmit and receive, and now this is the baud rate, which must match the baud rate we set on the actual XBees. So this was 9600. Select that. And then the last thing we'll change is the buffer size, which we will make 5. And what that does is it enables the internal receive interrupt, which we are going to use in this project. So that's it there. We'll click apply, hit OK. I'm going to rename these pins XB_TX and XB_RX. And the last thing we'll need is an ISR for our UART block. And we want it to interrupt on receive, so we're going to wire it to that. And I'll call the ISR XB_ISR. So that's everything we need here. So next we're going to do our CYDWR file. So we have 4 pins we're using here. The first one is button in, which we're going to wire to the button on 15.5. The LED we're going to use is 6.3. And then the wire we have on the breadboard for the receive is 6.0. And then for the transmit it is 6.6. That's everything we need there. So last thing will be the coding. So go to your main file. First thing I'll enter is the send data variable. This is simply the 123 I was talking about earlier that we'll be sending from the PSoC to the MATLAB XBee when the button is pushed. And then we'll be using 2 flags for this project that are going to come from files that are external to this one. So we're going to extern command_received, and then a second one that is button_flag. So we do want the global interrupt, so I will uncomment CY global int enable, and then I will start the various blocks we have. So first is XBee_UART_start, start the UART block, and then we are going to enable the receive interrupts. So that is enable RxInt, and then we'll start the button ISR start and UART_ISR_start. Let me just verify that those names match. Oh, so sorry, it's actually XBee_ISR_start for the ISR on our UART block, and the rest appears to be correct. So now in our for loop, we're doing very simple. We are just checking for the flags that we are going to externally be setting. And so the first one will be the flag for the button. So I'll say if button_flag. And in here I'm going to say XBee_UART_putchar and send data. So what this will do is when the button flag is set, we'll simply send the send data variable, which is 123, through the XBee. And so this will get transmitted from the PSoC XBee to the MATLAB XBee. So now we want to clear the flags so that in our for loop this doesn't run over and over. So we'll set that to 0. And then we'll put a small delay, because with the buttons, if you don't put a small delay, it can run over and over and over. So then the other flag we're checking for is command_received. And this is when we receive a 1 or a 0 from the MATLAB XBee. And so what we want to do then is toggle our LED. So if it's a 1, I'll say LED_out_right 1 to turn it on, and else LED_out_right 0 to turn it off. And that looks like it's lowercase in the top design. And everything else appears correct. Okay, and now, since we now need to edit the files that have not been generated yet, I'm going to build this project. So after the files are generated, we're going to go into the button ISR and we'll be going into the XBee ISR, and that's where we'll be setting those flags. So it doesn't recognize those because we haven't created them yet. So now we've generated our ISR, so I'll go into the button ISR. And where we enter our declarations here, we are going to include button underscore in dot h, and then we have our button underscore flag equals 0, and that's the variable that we externed in main. So now we'll go down to the actual ISR, and we'll call cy get reg 8, and we'll use button in stat, and then we'll set our flag button flag equal to 1. So what this does is this clears the register associated with the button, and we're setting our flag to 1. So that's all we need to do here. And then the second ISR is the XBee ISR, so we'll open that up. And again, in the declarations near the top, we'll include the XBee underscore uart.h, as we'll be referencing that, and we'll include this variable that we externed in main, which was command underscore received. We'll initially set it to 0. So now we'll go down to our ISR. And what we want to do here is if the character that we're receiving from the MATLAB XBee is a 0, we want to set command receive to 0, and if the character we receive is a 1, we want to set command receive to 1. So that way in main, we'll be toggling the LED appropriately. So first, I'm going to clear the interrupt associated with the receive interrupt, and then I will create this variable received char, and what this represents is the character that we're receiving from the MATLAB XBee. So now we'll check if the received character is a 0, or if it's a 1. So if it's a 0, we'll set command received to 0, and if it's a 1, set command received to 1. Okay, so that's everything we need there. Just make sure that we have everything. Main function is complete. So after all that, rebuild the project, and then program the dev kit. And now the dev kit will be programmed, and we're ready to move on to the MATLAB.
We're going to demo the lab now with the dev kit with our XBee plugged in, and the other XBee into the adapter that is going to be integrated through MATLAB. In the MATLAB command window, we're first going to open a serial connection to the MATLAB XBee. Type XBee equals serial. Now we'll type the COM port, which you'll have to look up. For me, the XBee is on COM 3. We'll set the baud rate, which we previously set on the XBee to be 9600. And then we're also going to open that serial connection. So we'll type fopen XBee. Now our serial connection with the XBee is established. And so now we want to demonstrate that when a button is pushed on the dev kit, we're going to receive number 123 as we coded earlier. So I'm going to type fread XBee, and we want to receive 1 byte. So I'll type that, I'll enter it, and now MATLAB is blocking until I hit the button, and you see 123 comes across. So Now we're going to go the other direction where we're writing things from the MATLAB XBee to the DevKit XBee, and as we coded, this will turn on our LED P6_3. So I'm going to type fwrite XBee and a 1 because we want to turn the LED on, and you'll see on the DevKit that our LED P6_3 will turn on. Now if we want to do the same thing but turn it off, we'll write a 0, send that across, and the LED turns off.